Welcome everyone to the Open Programming Mini-Conf here at LinuxConf AU 2013. This is the fourth time we've run this mini-conf as a way for developers using open source tools on various platforms to share their experience and techniques that they've developed using open source development tools. It's gone pretty well over the past few years, so they've invited us back for this year. I hope that you enjoy the program that we've got lined up for you today. I think we've got a really good range of talks over a very wide range of developer-related topics. A couple of housekeeping things to mention before we get on to our first talk. Up the back of the room, you'll see a whiteboard there, and on the right-hand side of that whiteboard are 9 free spaces for lightning talks, which we're going to be presenting at the end of the day. If you have a 5-minute rant or demonstration of something that you think you could present to the audience here, we'd absolutely love it if you did. Put your name and your topic up on the board there. Secondly, this mini-conf really prides itself on having quality recordings of all the talks come out at the end of it. So if you wish to ask a question, ideally wait till the end of the talk and wait for a mic to get up to you so that we get your question recorded. If you wish to interrupt or heckle, also raise your hand and I'll bring a microphone for you to do that as well. I'm not going to waste any more of your time. I'm going to take you straight to the first talk. Our first presenter is a real friend of this mini-conf. She helped run the thing in 2010 and has presented at quite a few of them since. Jacinta runs Perl Training Australia and who offer courses in Perl throughout Australia. She's presented at various open source conferences and Perl conferences throughout the world and is presenting here today at the Open Programming Mini-Conf. So presenting Solving Interesting Problems by Writing Parsers, please welcome Jacinta Richardson.
Thank you and good morning. Sound okay up the back? Yep. Awesome. Okay. So I'm going to tell you in this talk about a problem I had recently from a client that I was working on. And before I do, I want to acknowledge, yes, Perl has some great parsing modules. Here are 3 of the very popular ones, but I'm not using any of these. And Chris mentioned fun. I wanted to make the programming fun again, because when you're writing code, it should be fun. Perl especially should be fun. And what do I find fun? Well, I find roller coasters fun and parties fun, and I found the beach fun, but that's not really helpful for this talk. What do I find fun about code? There's a bunch of things that really, really enhance it. And the biggest one is not repeating myself. Every time I find myself cut and pasting code from before, or repeating myself, or even having something that ends up looking really close to something I've already written, I'm like, no, this is not fun anymore. I don't want to be repeating myself. Whoa, don't hit that button. So, parsing. This talk is about parsing some rather interesting data. And I solved it using regular expressions. Now, I know that in most parsing situations, regular expressions are the wrong solution. So some of you are probably thinking that, oh no, I'm not parsing HTML, I'm not even parsing vaguely free-form data. So regular expressions were the right solution, and I'm going to show you why. But first of all, I did it because, and I particularly want to say I was using named captures. Perl didn't invent this. Perl stole this from a bunch of other languages, so there's a very good chance you have access to named captures as well, possibly with a slightly different syntax, even if you're not writing in Perl. Just to give you an idea of what, I've got to stop doing that. What I'm talking about, if we go to this problem here. Here I'm matching title, name, and then I want to capture surname. But what capture number, what capture variable is $surname going to be in? It may not be in $1, because if $title or $name have their own sets of parentheses inside them, that's going to increment our match variable number. So this doesn't work real well. And I'm sure some of you have encountered that. So match variables make this easier. I could say, I'm going to match this thing and I'm going to put it into the variable surname, And then later I'm going to pull it out of the stupidly named hash percentage plus. But because I'm doing a lookup here, it's dollar plus. And that's what Perl decided to put it into it because all the better named hashes were already taken. There's also dollar minus, but we don't need to worry about that for this talk. Oh, sorry, hash minus. Now, the other thing you need to know to make this work really well are define blocks. Define blocks allow us to specify rules, not captures themselves, but things that help us create our captures. And we could do this, for example. I want to match the title and put that into the title field, the name, and put that into the name field, and I want to match surname, put that into the surname field. But what does title, name, and surname look like? Here's my rule set, my define block. Now, nothing inside the define here captures. Even I could put as many sets of parentheses in there as I like. Nothing inside there captures. Nothing is remembered. But these are rules that I can use later on. Now, this can be really, really helpful for all manner of things, and this is what I'm going to take great advantage of to make my project work. So what is my problem? I was asked to parse some data from ASIC, the Australian Securities Information Commission. Now, ASIC provides a whole bunch of information about businesses. You can do a search for certain types of documents. You can do searches for ABNs and all sorts of other things. Organization extracts and so on. My client wanted about a dozen of these different records. And I was like, sure. Okay, let's have a look at what the data looks like. So they give us this table that looks kind of like this. Here's a fragment of the data definition. It's all easy stuff. If we look at the type field, D is, it just has digits. N is, it has numbers, which seem very much the same thing. AN, it's alphanumeric. So a date field is 8 digits, or the word unknown. A time field is 6 digits. An org name is 200 alphanumerics, which is actually allows a certain amount of punctuation as well, because really they mean printable. And on the far left, we have the ID field, 001, 002, 003, all the way down. It goes beyond 18, but this gives you an idea of what the data looks like. And this is really easy stuff to encode. Here's my rule set, my define, that specifies all of this. So I start my define, I say printable characters look like this, numerics are just digits, and my 001, just like in the previous table, is 8 digits or unknown. My 002 is 9 numerics, which is just 6 digits. And this is nice. I've got a define block. I can just copy that data and say this is what everything's going to look like. So far it's easy. Now it gets a little bit harder. Some fields are composite. So I have a person name consists of a family name followed by a tab, given name followed by a tab, given name 2 followed by a tab, given name 3 followed, well actually not followed by a tab, because this is all tab separated data. And I want to point something out there. The last two given names here, given name 2 and given name 3, are optional. The C stands for conditional, essentially means optional, which means that they might not exist. And if given name 3 doesn't exist, then the tab before it won't exist. And if given name 2 also doesn't exist, its tab will be missing as well. And then they go and put these things like in the middle of their data. Blah, 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 followed by a name, followed by blah, 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 followed by an address. This is a little bit scary, but it works out okay. And it works out okay because regular expressions are backtracking. And then I didn't have to worry about it anymore. Oh, and leading fields can be optional, but they always have their tab. So they'll just be blank tab, blank tab. ASIC seems to think, this is their, of course, their own imaginary data format that they created. ASIC seems to think that this is fairly straightforward. It kind of works out in the end. So here's the data definition bit for that. So for my given names, the first one is required, and the next one is required, and the next one is optional, so we have to say, and that's tab might be optional, and so is the next one. And down here we've done a similar thing with the address. The last the only thing required in the address is the locality. And for those who are noticing that I forgot a couple of extra question marks in the name, yes, you're right, I only just noticed that too. But as I said, this is something that backtracking will help us with. If an address field comes out to have only 4 pieces in it instead of the 6 that it's supposed to, and then it's missing some tabs, and then I have something else, which would then logically be part of the address, except it isn't, it actually works out in the end. So let's have a look at what the actual data looks like. This is a report definition, and this is only a fragment thereof. So this is for the DSDD report, which is about document details. So we have a line that will start with YHD, followed by a bunch of fields. Then a new line. Then 0 or more, actually 0 to 10. We can know it because there's a C next to the 2 there in line number 11, that this is 0 or more, as in it's conditional. There'll be 1 YRJ followed by up to 5 YTEs. And then that will repeat up to 10 times. And then down here, YDO will be 0 or more as well. This seemed really kind of scary when I first got it. I'm like, what on earth am I going to do here? We can work out the numbers here, the 0018, 0012. That's our code for where we're going to look it up in our data definition. That's the ID, which is actually kind of handy. And let's have a look at an example report. So here's an example report. We can see our 3-character code to tell us what kind of line it is, and then our fields. These are tab separated, except there's no tab immediately after the line definition. The spec doesn't say that, but you can kind of work it out pretty quickly. So YHD, 0 or more YRJs, 0 or more YDOs, followed with YSHs and so on. Okay, so how do we match this stuff? Well, YHD record, look for YHD, the next string is actually required, it tells you that. And then I'm using named captures to say, look for message version, it's not optional. Look for a jurisdiction, it's not optional. All the way down to client reference, which is optional. Message trace number, which is also optional, but the next 2 aren't. What was really frustrating is that almost every report has a YHD line, and they're all subtly different. So you can't even say, here's a function that just does YHD. No. But so YHD appears only once. So we can match it like this. If we match that pattern, then unpack this stuff from our hash. And that's nice and easy. YRJ appears multiple times. 0 or more, really. But we'll go with multiple. So this is slightly different. While we can do our match, because we need to loop over each of these, then we unpack them from our hash called plus and put them into our data structure that we're building up. We want to build up a data structure of this information because that gives us much easier ways of dealing with it. Now I'm repeating myself, and that makes it not fun. Whilst none of that code was identical, I'm doing this. There's my rejection code, and there's my rejection code, and there's my rejection code, and I'm writing that 3 times. Or if you're like me, you're using Vim's autocomplete. And you're just hoping that you get rejection code and not, I don't know, rejection number or something like that. I don't want to write these 3 times, and there must be an easier way. So I thought, well, it's kind of obvious, right? What's in my hash? My hash has some keys, so let's have a look at them. Oh, how convenient. I actually worried it would have all this other stuff thanks to the define, but it doesn't. It just has the named captures. So that makes it really easy. Instead of writing this, I can do that. And now I'm only writing each name once. And I'm not repeating myself. So I'm almost having fun. Except I am still repeating myself. I've got this whole once versus many. If the line appears once, I do it with an if. If the line appears multiple times, I do it with a while. Now, I could believe their data definition and go, well, lines will just appear a certain number of times and I don't care because I'm not really validating their data. But I do actually want the data structure to look slightly different. I don't want to have an array reference of one item for single blocks, for example. So let's compare these. On the left, I have my if block. If I match, pack it into my data structure. On my right, I have my while block. If I match, then for each match, or while for each match, do this and add it to my data structure. And I'm repeating this bit here, this for each loop on both sides. So I'm repeating myself. I'm writing the same code or I'm cut and pasting it, and that's not fun. Maybe we can generalize this idea into a subroutine. That'd be the right plan, right? So I thought about this a long time, and this is the subroutine I ended up with. Unfortunately, it's sort of broken by a line up there, but I called it data from line. It takes a line, a pattern, and whether or not we're looking for a single thing. Then walks over our data. If we are looking for a single thing, we stop after the first iteration and back up one for our data structure, and we return our data. And then we do our loop. And now we're only doing that loop once, which means we're not repeating ourselves, so it's more fun, right? Now, two cases generalize to this, and the only difference is whether or not we have a single or not single entry that we're looking for. Single or multiple. And yet, damn it, I'm still repeating myself. Those structures look really, really similar to each other. So if I'm writing those each time, for every single time I have a different line definition, I'm doing that all the time. That's not fun. So we can refactor that. I don't want to have to write each of those, here's a pattern, call get line from data for each thing, and of course I don't have to. But I thought I'd generalize this a little bit better. I went, okay, so let's have a hash with the data in it. The lines that match YHD have a pattern and whether or not they're single. Later I can throw other things in here, such as, for example, better names for this data. Rather than YHD, I can call this a header. Instead of YRJ, I can call this errors. It's error in document request, whatever you like to call them. So now my parsing code looks like this. For each of the line types I'm expecting, so basically for each record I'm expecting, look up so they're my record types, get the data from the line, and look up the hash to get the pattern and whether or not it's a single thing. And now I'm not repeating myself, which is awesome. And I'm having fun because now I can just do this for each type of record I have, for each report I have, it's over really quickly, right? But, well, if you look at our data again, remember this? YDO has a certain number, 0 to 5 YSH lines. And what we've just written doesn't quite fit that. And so I was like, why are you making it so hard, ASIC? Because it's ASIC, why would I ask? Okay, so we can find the parent record and get it, and then go through all the sub-records and get those, because there's no reason why it can't have more than one sub-record type, and eventually save the whole data structure, and it would look kind of like this. So while I'm match, push the thingy on, and get the next ones, and get another line, and repeat, and then add it to my data structure. And that works beautifully. It really does. Well, at least the code it's based on works. There might be a bug in that. I can't spot one though. And then I'm repeating myself again, right? So I've got this call to get data from the line, I've got this other call. If I had more of these things, I would probably be walking over a loop. And how do I collapse this down to make this fun and short and usable and go back to the stuff I want to do, which is the regular expressions? So I can add something. I can say for each field, is there associated stuff? And then if YDO, in this case it has YSH, but if I don't know it had XYZ and ABC in there as well, I could put those in. And at least I can rely on ASIC to put them in order. So I know that I will first have to look for YSH lines, and then XYZ lines, and then ABC lines, and I don't have to worry so much about whether or not they're going to be in a different order and I have to randomly pick them. So that bit at least I can rely on. And to parse that, we end up with something like this. If we have an associated thing, handle my loop. Otherwise, just do the thing that we expect to do. And we just do this in our for each loop. This is the expanded for each loop from before. So for each by line type, YHD, YRJ, and YDO. We don't put in YSH in here because it's a sub-record. We don't want to look up the sub-records as well. We just want to, the YDO bit is going to handle that in this bit that says handle loop. And that bit that says handle loop kind of looks like this, which is a bit longer than it should be. Again, so while I can read in my line, it's pretty much the same thing I had before, but we're doing the test. If I have anything that's associated, which I've already tested before, but there's a reason I put this in here, then loop over everything that's associated and get my line back. Now there's a thing about this code that I found really interesting. And I'm sure that if you were writing this code, you'd go, aha, yes, as well. If we didn't have a record that had any associated records, but somehow it snuck through into this loop anyway, it'd kind of look like this. And that looks really familiar. I realize that you haven't memorized all the slides and I'm going through this code rather quickly. But this is something we've already done. While we can do stuff, get all the lines out, and move on, is stuff that we've already done. In fact, if we didn't have this, then we wouldn't need the while loop because the push data bit essentially happens, the get line has a while loop inside it. So this is kind of cool. So what we do is we take this idea and we just take this whole loop wholesale and we put it back into that get line from data function. And we say, just if there's associated stuff, deal with it otherwise, because it just doesn't appear otherwise, essentially. And we skip it. Now I'm not going to show you the code for that bit because I am certain that you can imagine it. Completely confident that you can imagine it. So pretend that we have fixed get line from data to handle associated fields. And now our parsing looks like this. For each my line type, YHD, YRJ, YDO, get my data from my line, get another line, and that's it. How awesome. Now I have this, I write this for every major line I have in my record. I then grab my, I create that hash I had before, which has my patterns in it, and I give them appropriate data attributes, and I can have time to have fun. My project becomes much easier, it's way easier to test, and everybody is happy, and my client is delighted because potentially we can ship on time. Potentially. It depends on the other code that is not related to this fun parsing problem. Now if you're curious, the final parsing kind of looks like this. Oh, sorry, parser. This is in YAML because that's what I was converting it to in my interim stage. So there's a few pages which I don't really expect you to look at, but look how beautifully it comes out. And yeah, I skipped a record, but I didn't think you'd count. Some things I didn't cover were how to handle the parsing errors and exceptions, because I am running out of time. I didn't cover edge cases because there are a couple. In particular, I didn't cover overflow records. If you make a request and you get back an error saying, hey, that didn't work, ASIC passes you back something that's like 5 lines long, not handling that. And if, unfortunately, I'm not validating the data set. They give me back 10 records and they say they'll only give me back 5. I don't care. Overflow was more fun though. Now, I do have very, very little time because I believe that I probably should have stopped about 5 minutes ago, but are there any questions?
So are there any questions for Jacinta? Raise your hand so I can see you, and now I'll just have to run over to you because you're in the wrong aisle.
Because Chris needs exercise.
Are you going to put this on the CPAN?
I'm not really sure that it would be of sufficient general appeal, but if I talk to my client and they're happy for me to do so, I will.
Can you switch this to document camera before you unplug and you start setting up?
Yep.
Any more questions for Jacinta? Yep. Oh, in the middle. not a problem.
Two related questions.
Yes.
Firstly, why didn't you look up by the start of the line rather than iterating over the types? Because it looks as though it's structured so there's a unique string at the start of each line that tells you how the rest of the line should be parsed. You don't necessarily need to know the rest of the structure.
Oh, you would so love to believe that, wouldn't you? The very first record I had a repeating token every hand-wavy number of lines, records that indicated where we were up to that still started with its own, the same code all the way down. And many of those blocks in between were conditional or optional. So you could go from this is a marker for we're starting the third kind of block to this is a marker for we're starting the 10th type of block, like that. And it was...
Right, so the data's broken.
The data was challenging, shall we say.
Right. Second,
Your related question, did you have one?
So I'll let you ask that later on. Unfortunately, we really are running tight on time. So everybody please thank Jacinta for her talk. Now there's been a bunch of people waiting patiently at the